In this video, we're going to continue our work with parametric equations and look at points of intersection. Let's start off with the coordinate axis. A question might ask us to find the points of intersection of the x and y coordinate axis given a pair of parametric equations. So let's just choose a pair of parametric equations and say that x is equal to 4t squared minus 16 and y is equal to 3t. So we have now x as a function of t and y as a function of t. What we're going to consider now is where these points of intersection are going to occur on both the x and the y axis. So let's get those up, and we'll have the x-axis here and then the y-axis. The curve will cross now the x-axis when y is 0, and it will cross the y-axis when x is 0. So let's consider now the y-axis. What we can say then is the y-axis, x will be equal to 0. Therefore, we can say that 4t squared minus 16 is equal to 0. What I'm looking to do here is solve for t and plug it back in to the second equation here to find the value of y. So adding 16 and dividing by 4, t squared is equal to 4, and t will be equal to plus or minus now the square root of 4, which is 2. So t is plus or minus 2. We can say when t is equal to positive 2, y will be equal to 3 lots of 2. So we can see straight off this is going to be the point here, 0, 6. We can say now when t is equal to minus 2, we can say that y will be equal to 3 lots of minus 2. That will give me the point just here, 0, minus 6. So that now considers the y-axis, and that's where x is equal to 0. Let's now consider the x-axis, and the x-axis will be where now y is equal to 0. So where y is equal to 0, 3t is equal to 0, therefore t is equal to 0. So we can say when t is equal to 0, we're going to have x will be equal to 0 minus 16. So we'll put this point just here, and that will be minus 16, 0. Now, if I sketch this out, let's just bracket that off. If I sketch this out, this is going to give me a parabola. I can see that, I can spot it from the equations here, but we'll just draw that anyway. So the question is done. All we were asked for is the points of intersection. Just now, to complete this, I'm just going to sketch the curve. We certainly aren't asked to do that. We're just asked now for 0, 6, 0, minus 6, and then minus 16, 0. That is the question complete. Okay, if I wanted to, just again to extend this on, I could put this in Cartesian form by eliminating the parameter t. Not part of the question, but we'll do it anyway for a bit of practice. We can say that t is going to be equal to y over 3, simply by dividing the second equation by 3. Therefore, x will be equal to 4 lots of t squared. Well, that's y over 3, which we need to square, and subtract away 16. X will be equal to 4 over 9, and then we'll have y squared minus 16. This now is a parabola opening outwards from its side. It's got now the symmetric line right here, so its axis of symmetry is the x-axis, and here x is a function of y, and we've got a parabola. So if you were given it in this form, if you wanted to know where it crosses the y-axis, we would set x to 0. If we wanted to know where it crosses the x-axis, we'd set y to 0. But we've done it now in parametric form. So there we go. Nice and straightforward. All we're doing is finding the values of t that work for this and plugging them back in. Okay, let's do another one. Let's say we've got now x is, let's go for x is equal to 4 cos theta. So x is equal to 4 cos theta and y is equal to 3 sine theta. So this isn't going to give us now a circle, as the coefficients are different on cosine and sine. Let's consider what we're going to have. We're going to have the coordinate axis, and we're interested now in where this crosses both the x and the y axis. Over here, I'm just going to draw the sine and cosine curves. You certainly don't have to, but it might help you in terms of finding your values. So what we're going to have is the following. If we look now at the sine curve, y is equal to sine theta. We will take this from 0 to 2 pi. So we'll come up, round, like so. If we take y is equal to cos theta, between 0 and 2 pi, we'll come down, we'll come back up, and we'll come round. Not accurate, but hopefully you get some idea of where we're going. 0, 0, pi by 2, 1. We've got pi, 0, 3 pi by 2, minus 1, and 2 pi, 0. With cosine, 0, 1, pi by 2 comma 0, pi comma minus 1, 3 pi by 2 comma 0, and then 2 pi comma 1. So here's sine and cosine. Let's now consider the y-axis. So y-axis, we can say now when it's going to cross the y-axis, x will be equal to 0. That means 4 cosine theta or 4 cos theta is 0. So we can say cos theta is 0. What I'm doing here is solving for values of theta, and then I'm going to plug it into y. So let's consider where cosine is equal to 0. It's pi by 2 and 3 pi by 2. So we can say that theta is equal to pi by 2 and 3 pi by 2. All I'm going to do is sub these in now. So what we've got is these values, and we'll put them in for y. So y, when theta is equal to pi by 2, y will be equal to 3 sine of pi by 2. 3 lots of a sine of pi by 2. Well, the sine of pi by 2 is going to give me 1, so that's going to give me 3. So we can say that this is going to be the point 0, 3. If we consider now when theta is equal to 3 pi by 2, sine of 3 pi by 2 is going to be minus 1. So y will be 3 sine of 3 pi by 2, which is going to give me minus 3. And that will be the point just here, 0, minus 3. If we now consider the x-axis, so the x-axis, we can say that y will be equal to 0. Therefore, 3 sine theta is equal to 0, and sine theta will be equal to 0. So if we look at sine theta equal to 0, 0, pi, 2 pi, and subsequent multiples of pi. So theta will be equal to 0, we'll have pi, and we'll have 2 pi. We know that 0 and 2 pi will give us the same value, and will be 1 over here and back over here. So what we're going to do is simply sub this in now. So we can say x is equal to 4 cos theta. That's what we know from here. So we can say now when theta is equal to 0, x will be 4 cos of 0. Now if we consider cos of 0 gives us 1. So that's going to be the point just here, and this will be 4 comma 0. If we now consider when theta is equal to pi, so when theta is equal to pi, we can say x will be equal to 4 cos of pi. Cosine of pi gives us minus 1, so we can see that that point there is going to be minus 4 comma 0. Now this gives us an ellipse, so we found the points of intersection. We don't need to draw it, but again I'm just going to draw it anyhow, and that will give us the ellipse like so. So I'll come round and we'll have something looking like that. Now we could have converted this again if we liked using our understanding of trig identities. We've done the question, but again I'm just going to do this part for completeness. Cos squared theta plus sine squared theta is equal to 1. Therefore x over 4, which we square, plus y over 3, which we square, is equal to 1. So we can say x squared over 16 plus y squared over 9 is equal to 1. And that gives us the equation of the ellipse. So there we go. That's now looking at points of intersection with the coordinate axis given two parametric equations. We're essentially solving for the value of theta and plugging it in to the other one. And in the last one, solving for t and plugging it in. We're now going to move on and look at points of intersection between curves and lines or other curves. So let's take again some parametric equations. Let's say we've got x is equal to, let's go for t squared plus 1, and y is equal to 3t minus 2. So here are parametric equations. X is a function of t and y is a function of t. We might be asked now for the points of intersection with the straight line y is equal to x minus 1. So what I'm going to do is look at this now and go ahead and find the points of intersection. So I know that x is t squared plus 1. I now know that y is 3t minus 2. I can now put this all in terms of t. So the left hand side, y, which is 3t minus 2, is equal to x, which is going to be now t squared plus 1 minus 1. So if we just rearrange, 0 will be equal to t squared minus 3t, that's going to be 0, and then we're going to get plus 2. So if I factor this, 0 will be equal to t minus 1, and then t minus 2. So we can say from here that t is equal to 1 or t is equal to 2. Now let's consider this right here. When t is equal to, and that's right here, when t is equal to 1, we can see that we're going to have x is going to be 1 plus 1. So we can say that x is equal to 2. In an exam, do show your full workings. And we'll consider now that y is equal now to 3t minus 2. So if t is equal to 1, we're going to have 3 lots of 1 minus 2. That's going to give me now that y is equal to 1. So all I've done is gone ahead and subbed that in. So we got these values right here. So the coordinates are going to be 2, 1. If we now consider when t, so let's write this here, when t is equal to 2, so t is equal to positive 2. Let's go ahead and do that. So when t is equal to 2, subbing in, we're going to have x will be equal to t squared plus 1, which is 5. And then we're going to have now 3 lots of t, that's 6, minus 2, y is going to be equal to 4. So we can have now the point 5, 4. So all we've done is gone ahead and simply now solved for t in this equation and plugged it straight back in. Graphically, if we wanted to show this, it would look something, and I'll do a quick sketch given now a rough understanding of what this is going to look like. We're going to have now a point and the parabola, this is going to be a parabola and a line. The parabola will do something give or take like so. It'll come round and it'll look something like this. And then we're going to have this line, and the line will do something give or take again like so. Let's just move this into place, and that will give us our points of intersection. So the line will look something like this, and we'll have now these 2 points. So if you go ahead and convert this into Cartesian form, it will be pretty easy to see the rough shape. This is going to be now the point 2, 1, and this will be the point 5, 4. So this now is y is equal to x minus 1. And of course, if you convert this, adding 2 to both sides and dividing by 3, we can say that y plus 2 divided by 3 is going to be t. So y plus 2 over 3. So x is going to be equal to this value squared, which will be 1/9 the quantity y plus 2 all squared plus 1. And that's what we're going to end up with. So what we've got then in Cartesian form is the intersection of these two. You wouldn't be expected to do that, but that gives you some idea. This point right here is going to be now, the y coordinate of this point is going to be minus 2. So that's approximately, give or take, what we end up with. So we got this point here, 1 minus 2, and it'll look something like so. So there we go. That's a nice example of the intersection of a line and a curve. We might be given a curve and a circle to deal with. So let's have a look at that. Let's say we had now parametric equations, x is equal to, and we'll go for 2, let's say 2t squared, and let's say y is equal to 3t. So these are our parametric equations now. So we've got x as a function of t, y as a function of t, and then we might have, say, a circle in Cartesian form. Let's go for x squared plus y squared minus 6x, and then minus 1, and that's equal to 0. So if we look at this now, we've got these this Cartesian form, and let's just have a look at this now. If I just consider now, what we're going to have is the following. I could make now on here, I could make t the subject of here, so t is going to be equal to now y over 3. So if I look at x, x is going to be 2 lots now of y over 3 squared. So this gives me that x is equal now to 2 over 9, and that's going to be y squared. So I've just looked at that ahead, but of course what we can do here is just go ahead and find the points of intersection. So let's look at this right here. If x is equal to 2t squared, I'm going to sub this in right here. So what I'm going to get is 2t squared all squared, plus now y squared. Well, that's going to be now 3t. I'm just putting these in here, and we're going to square that. Minus 6 lots of x, which is going to give me 2t squared, minus 1 is equal to 0. So this is now going to give me 4t to the power of 4 plus 9t squared minus 12t squared minus 1 is equal to 0. So what do we end up with? 4t to the 4th minus now 3t squared minus 1 is equal to 0. That's going to factor. Let's do 4t squared, and then we're going to have plus 1. And then we'll have now t squared. So all I'm doing is factoring the quartic equation. T squared minus 1 is equal to 0. Okay, so let's just check I've factored that. 4 times by minus 1, that looks pretty good. So we can say now, consider this bracket is equal to 0. 4t squared plus 1 can never be equal to 0. Therefore, this doesn't give us real solutions. Therefore, what we can say then is t squared minus 1 is equal to 0, and t will be equal to plus or minus 1. So t will be equal to now plus or minus 1. So all we need to do is sub these in. So we can say now when t is equal to 1, we're going to have x will be equal to 2 and y will be equal to 3. When t is equal to minus 1, subbing in again, we're going to have x is equal to 2 and y is equal to minus 3. So that's what we get. It'll look something like so. Now if you wanted, you could go ahead and complete the square on this, show it as a circle, and we could probably even see what that does. So if we looked at this as a circle, it'd be x minus 3 all squared, now plus, and then we'd have y squared, and then we'd have that would be equal to 10. So that in Cartesian form is now the circle which I've completed the square on. So if we looked at this, and I'll draw a quick sketch to give some idea of what's going on here. I don't know how accurate I'll be with it, but hopefully you'll see now that we'll have something like so. So what we've got is the following. We'll have now the centre, and the centre will be 3, 0. We're going to have a radius now of root 10. Root 10 is just a bit more than 3. So let's go ahead and do that. Let's put that there. And it will look something, let's put this in place, it'll look something give or take like so. So let's grab that up and it will do something like that. Let's make this now look, let's grab that and put that just there. So what we've got is the following. That's roughly what it will look like now, and now we've got this parabola on here, and the parabola will do something like so. So let's have a quick understanding of this parabola. X is equal to 2/9 y squared, so that is going to do something like that. Okay, so that will open up there. So from this we can see we've got the points of intersection. We're going to have one just here and one just here. That's not massively accurate, but we can see that that's going to be 2, 3, and that's going to be 2, minus 3. So there we go, looking now at the points of intersection. Now, between what we found to be a parabola opening upwards and then in Cartesian form, the equation of a circle. You wouldn't be expected to sketch this in most exams, but it just gives you some idea of what you're doing. Okay, let's look at one final example and change the wording over. We might be given a point, and let's say the point is Q, and we're given the point now Q is 2t squared, and then we might have 4t. And we'll say now that Q varies, and it follows a locus. So you might be told now that this moves along a locus, for example, and we need to find the point where the locus crosses a line. And let's say the line is, let's say we've got, let's go for 3/2 y plus now 8 is equal to x. So what we're saying then is that the locus of this point right here will cross this line. So all we need to do is sub these in again. So if I look at this now, if I sub 4t into here, I've got 3/2, again 4t. What I'm trying to do is eliminate now the x and the y by subbing in a t. Plus 8 will be equal to x, which is 2t squared. So what we're going to have 2t squared. And then I've got now here, what's that going to give me? That's going to give me 6t. So minus 6t minus 8 will be equal to 0. So t squared minus 3t minus 4 is equal to 0. So let's go ahead and look at that. Can we factor out t plus 1 and then t minus 4 is equal to 0. And then what we're going to have is the following. T is going to be equal to minus 1. And t is going to be equal to 4. So all we need to do is sub those in. So we can say now when t is equal to minus 1, let's take minus 1. Now just think what this is saying. This now is giving me the point. So in parametric form, x is equal to 2t squared and the y coordinate is 4t. So all I'm doing now, if this point Q varies with t, all I'm doing is plugging these in. So when t is minus 1, x is going to be equal to 2. And y is going to be equal to minus 4. So we end up with this point now, and that will be 2, minus 4. So we can say now when t is equal to positive 4, subbing that in, that's going to give me 16. 2 lots of 16 is 32. So 32. And then we've got now on here, when t is 4, y is going to be 16. So y is going to be 16. So we'd have 32, 16. And again, that gives us the 2 points. What we've got here now is the following. Let's just have a look at this. This is going to be yet another parabola opening up on its side. This is now of the form at squared plus 2at. Again, not something you would be expected to recognise, but we'll have something that looks approximately give or take like so. And now what we'd have is some line, and this line, if we look at this now, we could rearrange it into y is equal to mx plus c, but essentially what we're going to have now is something that looks give or take like so, and it's going to meet somewhere way off up in this direction right here. So what we've got then, and we'll just sketch this on now, we've got the following. So this now is the locus of points. It's following this path right here. This point and this point are where we're going to meet, 2 comma minus 4, and then 32 comma 16. So as now the locus, as this traces out now from the values of t that we could plot, then we're going to have the point now where these two paths cross. So there we go. That is now looking at points of intersection given either a curve and a straight line, a curve and another curve.